So in this plot here, I've got 3 plots, 1, 2 and 3. This one was done at say 12 o'clock, 10 past 12, 20 past 12. So that's a 20-minute plot. That's the distance that this target has moved across the screen in 20 minutes. So the first thing we can do is see what his relative approach is. And I can do that by joining up the first plot to the last plot, drawing a line through it. I mark that line with a single arrow, with a circle around it. That shows that's our relative approach, the way that the target appears to be moving across the screen. I can extend that on. I'll just mark it with a pretty dotted line for this example. And I can see that the closest point that this is going to pass by the centre of the screen, which is our position, and we're observing both, this will be the closest point of approach. I can figure it out exactly by taking your parallel rulers, or in this case I'll be using a protractor. And I use the protractor as a square, and I line up the centre on the line and line up the 90 degrees with the rest of the general direction of the relative approach. And I'll move it up, keeping that same angle until I get to where it cuts the centre of the screen. So, where the centre of the screen is 90 degrees to our relative approach, we can mark that off. That's the nearest point that the target will be to the centre of the screen. And I call that the CPA. Closest point of approach. I can figure out the time of the CPA. I'll just gauge it very roughly here. By measuring that distance and comparing it with this. Now, if that's 0 and that's 20, you can see that's about 15, very roughly. So 15 minutes after the last plot is the CPA. Now, the way I can measure the time of CPA by using the calculator is by taking this distance here. Now, again, that this distance here is the distance covered by the target in 20 minutes. 0 to 20 there. And that comes to be 5.8. So if I take 20 minutes and divide that by 5.8, and then I multiply it by that distance here for the last plot to the CPA, that distance is 4.4. So put equals times 4.4, and that comes to be 15 minutes, which was exactly what we got. We doing it with our compass there earlier. So the CPA time is 20 plus the 15 minutes. So CPA is going to be, so we said this was 12 o'clock here, should mark that down as 12, 20. So I had 15 minutes, CPA will be 12:35. Next thing we'll do is figure out the other boat's course and speed. Now, what I didn't have marked on here was our own course and speed. We were doing 350 degrees at 15 knots. So, first thing I need to do here is apply our course and speed vector to this relative approach here. The relative approach is made up of our cosine speed and his cosine speed. So we're doing 350 degrees and we're doing a speed of 15 knots. So we're doing 15 miles in an hour. Divide that by 60 in order to see how far we go in a minute. And that's how far we would go in a minute, quarter of a mile. Times 20 minutes for the plot. And that gives us 5 miles. So we're covering, in the time of this plot, a distance of 5 miles. And I marked that we're going 350, so we lay our vector off in the opposite direction down here. I measure from the centre of the screen to the course that we're going. And again, I would use a parallel ruler or a roller ruler to make sure that this was accurate. Draw that line down to there, that's where W. Mark W to O, that's where way of on boat. And all that's left now is W to A. And that's the way of the other boat. And W to A, mark off with a single arrow as well. To figure out his course with my parallel ruler, I would tack that line down through the centre. In fact, I'll just move it up a pretty bit like this so they can see the centre of the screen and still keep that same angle. And if we go to the edge, we'll see that his course is 281. So what we've got so far is his CPA, TCPA, and we've got his course. We're also going to finish speed, and we'll also find that aspect. So CPA, don't think I've measured that properly. Okay, roughly got 1 mile, 1.0. Time of CPA was 12:35, which was 15 minutes. His course is 281. And what's his speed? Well, this is the distance that he's going in 20 minutes. So I'll measure that. That comes to be 5 miles. So he's doing the same speed as we are. To figure it out, I'll take 5 miles, divide it by 20 minutes, because that's the distance he's going in 20 minutes. Then multiply that by 60 to see how far he would go in an hour, and it's 15 miles. So his speed would be 15 miles, nautical miles per hour, so it's 15 knots. The aspect is, that's basically, if this is him here, going in this direction, and there's a line for him directly to us, that's the angle that we are in relation to his bow. And we name it red if it's on his port side and green if it's on his starboard side. He's going that way, so we're on his port side, so we can it'll be red. We're the centre of the screen. So to figure that out, I just draw a line, extend his WA, because that's his heading. Hardly see that. And draw a line for his A right to the centre of the screen. And it's that angle there, that's the aspect. I can measure it with a protractor. And if I tack the protractor like this, I'm going to make this a bit longer so we can see it. Get to the edge of my protractor. In fact, I'll run it right to the edge of the screen there. So that's, put the centre of the protractor right down its last position. So there's 0. And if we go right down here, there's 60. And it's, this will be 60, 65, 67. So it's right 67. Another thing I can do is, run your line right to the edge of the screen through the centre, then tack this line and transfer it through the centre. So we do this, we need to do this with parallel rulers again, so I'll just do it as best I can through this. And just mark a mark on here. So that's 281, which was his heading. I could have just used his heading, of course. So 281, so that's 10, 20, 30, 40, 50, 60, and that'll be 66, 67. Exactly the same, right 67. So just two ways of doing that.